For my math modeling project, I will be doing the quadratic equation for projectile motion. Question: an object is launched at 64 feet per second from a 192-foot tall platform. When will the object strike the ground? This question is given by the equation S of t equals negative 16t squared plus 64t plus 192, where S of t equals time in seconds. Solution 1. I will first solve this problem using the equation S of t equals negative 16t squared plus 64t plus 192. Since the question asked us how long it would take for the object to hit the ground, you have to set S of t equal to 0, because that's the height of the object when it's at ground level. So 0 equals negative 16t squared plus 64t plus 192. Now, as you can see, all three of these numbers are divisible by negative 16. So I'll divide each one by negative 16, and that will leave us with the problem 0 equals t squared minus 4t minus 12. And now you just use factoring to figure out how long it will take for the object to hit the ground. So this can be factored into t minus 6 and t plus 2. And so we have two answers to this problem. T equals 6 and negative 2 seconds. But since time cannot be negative, negative 2 is considered an extraneous solution, so it cannot be a solution. So our final answer is it will take 6 seconds for the object to hit the ground. Solution 2. I will now solve this problem graphically. As we showed the last problem, negative 16t squared plus 64t plus 192 also equals this: x squared minus 4x minus 12. Now plugging that into the graph and pressing graph, you get a graph of the function. Now to find the answers, we have to find the values of x where y equals 0. So you press second, trace, 2, and you find the two x-intercepts. The first one is x equals negative 2, and the second one is x equals 6. So as we said before, x cannot equal negative 2 because time cannot be negative. So we find out from the graph that in 6 seconds the object will hit the ground. Question part 2. An object is launched at 64 feet per second into the air from a platform 192 feet high. Now instead of figuring out when the object will hit the ground, we will now figure out the highest point the object will get to. So the question is modeled by the same equation, which is equal to t squared minus 4t minus 12. Solution 3. I will now solve the question by graphing this equation, negative 16t squared plus 64t plus 192. And in the last drawing, I showed that this equation is also equal to t squared minus 4t minus 12. But for the question being asked, this equation must be used because we're looking for the maximum of the object, and the other equation shows the minimum. So to answer this equation graphically, I will plug in that equation into the graph. Squared plus 64t plus 192. And there's the graph of the equation right there. And now instead of finding the x and y intercepts, the x-intercepts, which are right here and right here, we're going to find the maximum, which is right there. So that's the vertex of this point. So we'll press second, trace, 4 for maximum, and that will help us find the maximum for this point. So in doing this, we find out that the maximum equals the y-coordinate, which is 256. So the maximum of the object being cast into the air will be 256 feet. This is the Sources I used for my math modeling project.